Hey there, tech enthusiasts! Welcome to our channel. Today, we're going to explore the fascinating world of blockchain technology beyond Bitcoin. Let's dive in and discover the endless possibilities of this technology. So, you've probably heard a lot about Bitcoin, right? It's been the poster child for blockchain technology for years now, and for good reason. It really kicked things off. But here's the thing, blockchain is so much more than just the engine behind cryptocurrencies. Think of Bitcoin as just the first app on a revolutionary new operating system. That operating system, blockchain, has the potential to change how we interact with the digital world, how businesses operate, and even how we trust each other online. It's a foundational technology, and its applications are sprawling into areas you might not even expect. Today, we're peeling back the layers, moving past the crypto headlines and diving deep into what makes blockchain tick and, more importantly, how it's being used to solve real-world problems. We're talking about transforming supply chains, automating complex agreements, and even revolutionizing how we manage our digital identities. It's a journey into a decentralized future, and the implications are pretty huge. We'll break down the core concepts in a way that's easy to understand, even if you're new to the idea, and then explore some of the most exciting and impactful use cases out there. Our goal here is to show you that blockchain isn't just some abstract, complex idea for computer scientists. It's a versatile tool with tangible benefits across a multitude of industries. We'll look at actual companies implementing these solutions and the impact they're having. So, if you're curious about what lies beyond Bitcoin and how decentralization is shaping the next wave of innovation, you're in the right place. We've got a lot to cover, so let's get straight into it and unpack the power of blockchain.
So what is blockchain? Simply put, blockchain is a decentralized digital ledger that records transactions across a network of computers. It's a secure, transparent, and tamper-proof way to conduct transactions. When we say decentralized, what we really mean is that there's no single point of control or failure. Think about traditional databases. They're usually stored in one central location, managed by a single entity. If that central point gets hacked or goes down, or if that entity decides to alter the data, well, you've got a problem. Blockchain flips that model on its head by distributing the ledger across many computers. This network of computers, often called nodes, all hold a copy of the same ledger. This distribution is key. It means that for any new information or transaction to be added, a majority of these computers in the network have to agree on its validity. This consensus mechanism is fundamental to how blockchain works. It's not one person or one company calling the shots. It's the network collectively verifying and validating what happens. This inherent redundancy also makes the system incredibly resilient. Now let's talk about the digital ledger part. Imagine a traditional ledger like an accountant's book where every transaction is recorded line by line. A blockchain is a digital version of that, but with some supercharged features. Transactions are grouped together into blocks. Each block contains a list of these verified transactions, a timestamp, and critically a cryptographic link to the previous block. This link is what forms the chain in blockchain. It's like each new page in our digital ledger is securely stapled to the previous one. This chaining mechanism is what makes the blockchain so secure and tamper-proof. The link to the previous block is actually a hash, a unique cryptographic fingerprint of the data in that previous block. So if someone tries to go back and alter information in an old block, its hash would change. This change would then break the link to the subsequent block, because its stored hash of the previous block would no longer match. This discrepancy would be immediately obvious to the rest of the network. To successfully tamper with a blockchain, an attacker wouldn't just need to alter one block on one computer. They'd have to alter that block and all subsequent blocks, because the hashes would all change on at least 51% of the computers in the vast distributed network, all at the same time. This is computationally and practically infeasible for any reasonably sized blockchain network. This is what we mean by immutable. Once data is recorded on the blockchain, it's incredibly difficult to change or delete it. And then there's transparency. While not all blockchains are public, there are private and permissioned blockchains too. Many, like the one Bitcoin uses, are. This means anyone can view the transactions recorded on the ledger. Now, this doesn't necessarily mean your personal identity is exposed. Often transactions are linked to pseudonymous addresses, but the record of the transaction itself, what happened and when, is open for audit by anyone on the network. This transparency builds trust because everyone is looking at the same version of the truth. So, to recap that core idea, we have blocks of information like transactions or any other type of data. These blocks are secured using cryptography, making them difficult to alter. Each new block is linked to the previous one, creating a chain.
One of the most promising applications of blockchain is supply chain management. Companies like Walmart are using blockchain to track the origin, quality, and movement of goods. By using blockchain, companies can ensure the authenticity and quality of products, reduce counterfeiting, and improve food safety. Think about almost any product you own: your phone, your clothes, the food you eat. It's all gone through a complex journey, often involving dozens of stages and multiple companies across different countries before it reaches you. This complexity can lead to a lot of problems. One of the biggest challenges in traditional supply chains is a lack of transparency and traceability. It can be incredibly difficult to know exactly where a product came from, what conditions it was stored in, or who handled it along the way. This opacity can lead to issues like counterfeit goods entering the market, foodborne illnesses spreading because the source can't be quickly identified, or unethical labor practices going unnoticed. Data is often siloed within each company's private systems. This is where blockchain steps in as a game changer. By creating a shared, immutable ledger that all participants in the supply chain can access, with appropriate permissions, of course, blockchain can provide an unprecedented level of visibility. Every time a product moves from one point to another, or undergoes a change in status, say from farm to processor to distributor to retailer, that event can be recorded as a transaction on the blockchain. Imagine a head of lettuce. With a blockchain-based system, you could potentially scan a QR code on the packaging and see its entire journey, which farm it came from, when it was harvested, the temperature it was kept at during transport, and when it arrived at the store. This kind of detailed, verifiable information is incredibly powerful. For consumers, it means greater confidence in the safety and authenticity of what they're buying. Walmart, as mentioned, is a great example of a company pioneering this. They've been using blockchain, specifically IBM's Food Trust platform, to track products like leafy greens and pork. In the event of a food recall, what used to take them days or even weeks to trace the source of contamination can now be done in seconds. This rapid traceability is crucial for public health, minimizing the impact of outbreaks and helping to quickly remove affected products from shelves. Beyond food safety, think about combating counterfeit goods. The luxury goods market, pharmaceuticals, and electronics are all heavily impacted by fakes. Blockchain can help by creating a digital passport for each genuine item. As the item moves through the supply chain, its journey is recorded. Consumers can then verify the authenticity of a product by checking its history on the blockchain, ensuring they're not buying a knockoff. This protects brand reputation and consumer trust. This technology also enhances accountability. If every step is recorded on an immutable ledger, it becomes much easier to identify where things went wrong if a problem arises, whether it's a delay, a damaged shipment, or a quality control issue. This accountability can drive improvements across the entire supply chain, encouraging all participants to adhere to agreed-upon standards and practices.
Chapter 3. Smart Contracts. Automating Trust and Agreements. Host smart contracts are self-executing contracts with the terms of the agreement written directly into lines of code. They can automate various business processes, reducing the need for intermediaries and increasing efficiency. Companies like AXA are using smart contracts to create innovative insurance products and improve customer experience. Alright, let's dive into smart contracts, because this is where blockchain starts to feel less like a database and more like an active automated system. The term smart contract was actually coined by cryptographer Nick Szabo way back in the 90s, long before blockchain as we know it existed, but blockchain technology provides the ideal environment for them to truly flourish. The core idea is pretty elegant: automate the execution of an agreement. Think of a traditional contract. It's a document outlining terms and conditions, and if there's a dispute or a condition is met, you often need lawyers or other intermediaries to interpret and enforce it. A smart contract takes those terms and conditions and translates them into computer code that lives on a blockchain. Because it's on the blockchain, it inherits those properties of being immutable, transparent to the parties involved, and decentralized. The self-executing part is key. Smart contracts are designed to automatically execute the terms of the agreement when certain predefined conditions are met. It's like an if-then statement on steroids. For example, if a shipment is confirmed as delivered, an event recorded on the blockchain, then the smart contract automatically releases payment to the seller. No manual intervention, no delays waiting for someone to process paperwork. This automation can drastically reduce the need for intermediaries. In many traditional processes, intermediaries exist to build trust or facilitate execution. Think escrow agents, payment processors, or even certain legal services. Smart contracts can take over many of these functions because the trust is built into the code and the underlying blockchain. This can lead to significant savings in time and money and reduce the potential for human error or bias. AXA, the insurance company, provides a great real-world example with their flight delay insurance product called Fizzy, though it has since evolved. The concept was simple. You buy insurance for your flight. If your flight is delayed by more than a certain amount of time, say 2 hours, the smart contract, which is connected to a reliable flight data feed, automatically detects the delay and triggers an instant payout to your account. No claim forms to fill out, no waiting for an adjuster. This not only improves efficiency for AXA, but also dramatically enhances the customer experience. Imagine getting an automatic payout for a flight delay without having to lift a finger. That's the power of automating the agreement directly. The conditions, flight delayed by X hours, are objective and verifiable by the code, and the outcome, payment, is executed automatically. This builds a new kind of trust between the insurer and the insured. The potential applications for smart contracts are incredibly broad, spanning numerous industries.
Chapter 4: Identity Verification and Digital Identity, Secure and Sovereign. Host blockchain can also be used for identity verification and digital identity management. Estonia, a Baltic country, is using blockchain-based identity verification system for its citizens. Blockchain-based identity verification systems can provide secure and decentralized management of digital identities, reducing the risk of identity theft and improving data security. Now let's talk about something deeply personal and increasingly critical in our digital age: our identity. Managing and verifying identity online is a huge challenge. We're constantly creating accounts, sharing personal information with countless services, and trying to prove who we are in a world where data breaches are unfortunately all too common. Traditional identity systems are often centralized, meaning our sensitive data is stored in large databases that can be attractive targets for hackers. This is where blockchain offers a fundamentally different approach to digital identity. Instead of relying on numerous centralized entities to hold and verify our identity information, blockchain can enable what's often called self-sovereign identity, or SSI. The core idea here is that you, the individual, should have control over your own digital identity. You decide what information is shared, with whom, and for how long. Blockchain provides the secure and decentralized infrastructure to make this possible. Your identity attributes, things like your name, date of birth, educational qualifications, or professional licenses, can be cryptographically secured and anchored to a blockchain. You would hold the private keys that give you control over this information. This doesn't mean all your personal data is stored on the blockchain itself. That would be a privacy nightmare. But rather, verifiable claims or attestations about your identity can be managed through it. Think of it like this. Instead of giving a company a full copy of your driver's license just to prove you're over 18, a blockchain-based system could allow you to present a verifiable, digitally signed claim that simply states, yes, this person is over 18, without revealing your actual birth date, address, or license number. This concept of selective disclosure is incredibly powerful for privacy. Estonia is a fantastic real-world example of a nation embracing digital identity with blockchain elements. Their e-residency program and national ID card system utilize technologies like KSI, a keyless signature infrastructure, blockchain, to ensure the integrity and security of their digital identity services. Citizens can use their digital IDs to vote online, access government services, sign documents digitally, and much more, all with a high degree of security and trust. The benefits of a blockchain-based identity system are numerous. Firstly, enhanced security.
Chapter 5. The decentralized future is now. Host. As we've seen, blockchain technology has far-reaching applications beyond cryptocurrency. From supply chain management to smart contracts, identity verification, and more, blockchain is transforming various industries. So, that was a pretty deep dive into the world of blockchain beyond just Bitcoin and cryptocurrencies. It's clear that the underlying principles of decentralization, transparency, and immutability are incredibly powerful, offering innovative solutions to some really complex challenges. We've seen how it can bring unprecedented transparency to supply chains, automate agreements with smart contracts, and empower individuals with more secure and self-sovereign digital identities. And honestly, we've only scratched the surface. There are developments in voting systems, healthcare data management, intellectual property rights, and so much more. The key takeaway here is that blockchain is a foundational technology, much like the internet was in its early days. It provides a new kind of infrastructure for building applications and systems that are inherently more trustworthy, secure, and efficient because they don't rely on a single point of control. While there are still hurdles to overcome, scalability, regulation, user adoption, the momentum is undeniable, and the potential for positive impact across virtually every sector is truly exciting. It's about building a more distributed and equitable digital future. Host, thanks for watching. If you have any questions or topics you'd like to discuss, please leave a comment below. Don't forget to like and subscribe for more content on emerging technologies.